Hello everyone. So let's understand the Banker's algorithm with the help of example. So here three processes are given: process P0, process P1 and process P2. And we have three different types of resources: X, Y and Z. You can assume that X is either printer and Y is, let's say, scanner, and Z is some, let's say, other files or other things, hardware devices. So we have three different resources XYZ, here also XYZ, and currently process P0 is having one instance of resource X, which is printer, one instance of two instance of resource Y and one instance of resource Z. Currently it is allocated to the process P0. Similarly, process P1 is having two instance of resource X, 0 instance of resource Y and 1 instance of resource Z. And similarly, process P2 is having 2 instance of resource X, 2 instance of resource Y and 1 instance of resource Z. Apart from this allocation, which are currently allocated to the different processes, still the processes P0, processes P1 and processes P2 are needed these resources further to complete their execution. So here currently it is allocated and it requests further to complete their execution. So requesting for process P0 need one instance of resource X and 3 instance of resource Z to complete their execution. Similarly, process P1 need one instance of resource Y and 2 instance of resource Z. Currently it is allocated one instance to complete their execution. Similarly, process P2 requires one instance of resource X and 2 instance of resource Y to complete their execution, but currently it is allocated as 2 instance and 2 instance each. And we are given that there are total 5 units of each resource type. It means that from the starting phase, at the initial phase, X is having 5 instance of resource R, Y is having 5 instance, and similarly Z is having 5 instance. So you can say that total available is 555, and here 555 represent X, Y, Z. Now we are finding we need to find, if we allocate somehow to the resources from this given resources, then there will be a safe state or not. If that leads to a safe state, that means operating system would allocate to the particular resource to the given process. Otherwise it will not allocate it. So one is total available resources given, allocated table is given, and request table is given. Three things are given. Now the first step to solve this problem is, you need to find the available currently available resource. So total is given as 5, 5 and 5, and how many of them are allocated from the given total available resource. For allocated, you just sum up this number. So X will be 1 plus 2 3, 3 plus 2 5. Total 5 will be allocated to process P0, P1 and P2. Similarly, 2 plus 0 plus 2, which is 4. 4 instance of resource Y will be allocated to process P0, process P1 and process P2. And similarly, 1 plus 1 plus 1, which is 3. 3 instance of resource Z will be given to process P0, P1 and P2. Now, from the total, we need to subtract the allocated resource. So if you subtract the allocated resource, the result will be 5 minus 3 is 2, 5 minus 4 is 1 and 5 minus 5 is 0. So currently only one instance of resource Y is available, 2 instance of resource Z is available, and 0 instance of resource X is available. So from this available resource, we need to fulfill the request of at least one process P0, process P1 and process P2. So which process is generally fulfill the request by the given available resources? So if you see that here it requires 1 and 3. So generally we do not have any instance of resource X, so we cannot fulfill this request. And similarly, if you see that a process P1 here 0, 1 and 2, it is 0, 1 and 2, so we can fulfill the request of process P1. And check furthermore, here 1, here 2 and here 0. So here only one instance of resource Y is available, so we cannot fulfill the request of our P2 as well. So the only possibility of fulfilling the request of processes are process P1. So just try to allocate the process P1. It is available. If we allocate, assume that if we allocate these resources 0, 1, 2 to process P1, then after completing the execution, the process P1 will free up the resources 2, 0 and 1. So whenever you allocate, whenever you fulfill the request of any process, do not try to allocate them. Just assume that it is allocated and see what happens if the process is completed. After that, what instance of resources it will free up. So here process P1 will free up the 2 instance of resource X, 0 instance of resource Y and 1 instance of resource Z. So just add them the available process. So it will free up the 2, 0 and 1. Now the new available will be 2 plus 0 is 2, 1 plus 0 is 1 and 2 plus 1 is 3. So newly available parameter is 2, 1 and 3. Using 2, 1 and 3, it is already completed. Can we fulfill the request of any other process? Yes, we can fulfill the request of process P0 as well as no, we cannot fulfill the request of process P2. Why? Because here it is requested 2 instance of resource Y, but we have only 1 instance of resource Y as left. So we can only fulfill the process P0 request. Now available is 2, 1 and 3. Assume that process P2 request, process P1 request is fulfilled. Process P1 request is fulfilled. So here process P2, here it is process P2 and here process P1. Then after allocating 1, 0, 3, it will complete their execution, and after completing the execution, it will free up the resource of X, Y and Z simultaneously. So here it will free up the 1, 2 and 1. So the new available will be 2 plus 1 is 3, 1 plus 2 is 3 and 3 plus 1 is 4. Now only one process, which is process P2, is left. Can process P2, it is process P1, it is process P1, it is process P0. Okay, sorry for that, it is process P1, it is process P0. Now the last process is process P2. Can we fulfill the request of process P2? It is given as 1, 2, 0 and here new available is 3, 3 and 4. Yes, we can fulfill the request. So we allocate the 1, 2, 0 instance of resource X, Y and Z to process P2, and after completing the execution, it will free up the resource 2, 2 and 1. So just add them 2, 2, 1. Now the new available will be 3 plus 2 is 5, 3 plus 2 is 5 and 4 plus 1 is 5. So after completing all the processes, this new available should be equal to the total available resources which are initially given. So here it is 5, 5, 5 and here also it is 5, 5, 5. And after allocating the resources to the different processes, we are generally end up with a safe state. Okay. So here it is process P2. So the safe state will be what are the sequence of processes in which we achieve the safe state? Process P1 will be first, then after process P0 and finally last process is process P2. So P1, P0, P2 is the order to achieve the safe state. Okay. So this is the particular way to implement the Banker's algorithm and to find the safe state. If this state is not safe, then we move back to the previous state and find whether any other possibility to achieve the safe state or not. Okay. So in the next video, we will see some other aspects related to deadlock handling strategy.